Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Me and my team will present about Pytorch library. My team has 3 members. Me, Muhammad Miftahul Fadl, and then Crismanto Darmawan, and the last, Dafa Wiratama. There are 3 outlines. First, why deep learning libraries and why PyTorch? Second, a brief introduction to PyTorch. And the last, PyTorch in action. So we move to outlines 1. There are many libraries that are used to run deep learning algorithms, carry out studies, and solve problems. Today, existing libraries are constantly updated and new libraries are also available. However, among these libraries, there's no one that is completely dominant. Users work in different libraries based on their experience. Some of the libraries used to perform deep learning studies are follows: Caffe, Microsoft CNTK, MXNet, Caffe2, TensorFlow, Keras, Theano, Torch, PyTorch, Keras, and Fadl. And why Python is better than other libraries? PyTorch fit perfectly in the machine learning ecosystem. As it is developed to be used in Python top, it has a C++ interface. Compared to other declarative deep learning frameworks, PyTorch is popular for its imperative programming style, which make it more Pythonic. PyTorch leverages the flexibility and popularity of the Python programming language whilst maintaining the functionality and convenience of the native Torch library. And then PyTorch has dynamic graph, friendly API for research, easily debug, and more Pythonic. And then a brief introduction to PyTorch will present by Crismanto Darmawan.
To install PyTorch on your device, you can visit PyTorch website here and you can choose your device specification, and the website will generate a command for you to install the PyTorch on your device. This is the major component of PyTorch. There are Torch, Torch Autograd, Torch NN, Torch Optim, and Torch Utils. This is the description for every package. And there are some libraries for neural networks in PyTorch, such as containers, convolutional layers, recurrent layers, linear layers, nonlinear activations, and loss functions. There are 2 ways to code in PyTorch. You can use torch.nn or torch.nn.functional. In torch.nn, the module already has internal attributes like weights and bias. However, in functional just defines the operation and needs all arguments to be passed, including weights and bias. To load the dataset, you can import all the necessary libraries, access the data in the dataset, loading the data, iterate over the data, and you can visualize the data. For example, you can visit this link. And how to build the model? To build the model, you can use torch.nn or torch.nn.functional like before. And to train the model, you need to define the module and the loss function and the optimizer.
PyTorch in action. In this section, we will try to implement some model to tackle MNIST dataset using 3 different models with PyTorch library. And this is how the dataset look like in the image form and the metric representation. The first model that we will define is multilayer perceptron that has 28 times 28 input feature followed by 64 hidden layer and 10 output at the end. And here's the code represent for corresponding model. We only need to define two functions. The first one is to define how the model is structured, and the second one is to perform inference or forward propagation. Recurrent neural network. Same dataset as before, but different approach here. We input the image sequentially into the model, one row at a time. And here is some implementation in the Pytorch library. Same as before, we define two functions, one for declaring the layer and the second one is to performing inference. It is quite intuitive to use Pytorch. The last model that we will define is convolutional neural network to perform filtering across spatial domain. And here is some representation in the Pytorch library. Same as before, we only need to declare one classes and two function, one for declaring the layer and the second one is to perform inference or forward propagation. I think that's all from us. Thanks for your attention and see you next time.